We continue our discussion of nested quantifiers with example 15. Use quantifiers to express the statement that there does not exist a woman who has taken a flight on every airline in the world. Solution. This statement is the negation of the statement there is a woman who has taken a flight on every airline in the world from example 13. By example 13, our statement can be expressed as the complement of there exists W for all A, there exists F of P of WF and Q of F comma A, where P of WF is W has taken F and Q of F comma A is F is a flight on A. By successfully applying De Morgan's laws for quantifications for quantifiers in Table 2 of Section 1.3 to move the negation inside of successive quantifiers, and by applying De Morgan's law for negating a conjunction in the last step, we find that our statement is equivalent to each of the sequence of statements that's shown below. The complement of there exists W for all A, there exists F, P of WF, and Q of F is our original statement. Moving the negation operator through the there exists, through the existential quantification, we change it to the universal quantification for all W, the complement of for all A, there exists F, P of WF, and Q of F comma A. Continuing through this, and by moving the negation operator through the various existential and universal quantifiers, we arrive on the last line to for all W, there exists A for all F. The complement of P of WF or the complement of Q of FA, so that every quantifier has been changed into its analog. Every existential quantifier has been changed to a universal quantifier, and every universal quantifier has been changed to an existential quantifier. The last statement states, for every woman there is an airline such that for all flights this woman has not taken that flight, or that flight is not on this airline. Now we proceed to a few exercises like those that are assigned for this section. Exercise 3. Let Q of X, Y be the statement X has sent email message to Y, where the domain for X and Y consists of all students in your class. Express each of the quantifications in English. Part A. There exists X, there exists Y, Q of X, Y. There is a student who has sent an email message to a student in your class. Note, a student could have sent an email message to himself or herself because the quantification does not specify that X is not equal to Y. B. There exists X for all Y, Q of X, Y. There is a student who has sent a message to every student in the class. For all X, there exists Y, Q of X, Y. Every student has sent an email message to some student in the class. There exists Y for all X, Q of X, Y. Every student X has sent an email message to the same student Y in the class. For all Y, there exists X, Q of X, Y. A student X has sent an email message to every student in the class. For all X, for all Y, Q of X, Y. Every student has sent an email message to every student in the class. 9. Let L of X, Y be the statement X loves Y, where the domain for both X and Y consists of all people in the world. Use quantifiers to express each of these statements. Everybody loves Jerry. For all X, L of X, comma Jerry. Everybody loves somebody. For all X, there exists Y, L of X, Y. There is somebody whom everybody loves. For all Y, there exists Y for all X, L of X, Y. Nobody loves everybody. For all X, there exists y, the negation of L of xy. There is somebody whom Lydia does not love. There exists y, the complement of L, Lydia, comma, y. There's somebody who loves no one. Oh, excuse me. There's somebody who no one loves. There exists y for all x, the complement of L of xy. There's exactly one person whom everybody loves. Define the notation there exists exclamation mark to mean the existence of a unique object satisfying certain conditions. To use this notation, there exists a unique x for all y L of xy. Alternatively, we have x asserted here exists and that every z satisfying this condition of being loved by everybody must equal x. There exists x for all y L of xy and for all z, for all w, L of wz implies z equal x. H. There are exactly two people whom Lynn loves. We want to assert the existence of two distinct people whom we will call x and y, whom Lynn loves, as well as make the statement that everyone whom Lynn loves must either be x or y. There exists x, there exists y, x not equal to y, and L of Lynn x and L of Lynn y, and for all z, L of Lynn z implies z is equal to x or z is equal to y. Everyone loves himself or herself. For all x, L of xx. There is someone who loves no one besides himself or herself. This is asserting that the one and only one person who is loved by the person being discussed is in fact that person. There exists x for all y, L of xy, if and only if x equal y. Express each of these system specifications using predicates, quantifiers, and logical connectives if necessary. Every user has access to exactly one mailbox. We need to rule out the possibility that the user has access to another mailbox different from the one that is guaranteed. Define A of UM to mean that user U has access to mailbox M. For all U, there exists M, A of U comma M, and for all N, N not equal to M implies the complement of A of U comma N. There is a process that continues to run during all error conditions only if the kernel is working correctly. Define H of E to mean error condition E is in effect. Define S of xy to mean the status of x is y. Notice that the only if is the converse of if, so the kernel's working properly is a conclusion and not the hypothesis. There exists P for all E. H of E implies S of P running, implies S of kernel working correctly. C. All users on the campus network can access websites whose Universal Resource Locator has an edu extension. Define E of SX to mean that website S has extension X. Define A of US to mean that user U can access website S. For all U, for all S, E of S comma dot edu implies A of US. Part D. There are exactly two systems that monitor every remote server. We have to interpret the English sentence first, and different interpretations would lead to different answers. We will assume that the specification is that there exist two distinct systems such that they monitor every remote server and no other system has the property of monitoring every remote system. Define M of A comma me to mean that system A monitors remote server B. There exists X, there exists Y, X not equal to Y, and for all Z, for all S, M of ZS, if and only if Z is equal to X or Z is equal to Y. Translate each of these nested quantifications into an English statement that expresses a mathematical fact. The domain for each case is all real numbers. There exists x for all y, xy equal y. There is a multiplicative identity for the real numbers. For all x, for all y, x less than 0 and y less than 0 implies x minus y greater than 0. The product of two negative real numbers is always a positive number. I think that what this means is that there exists x, there exists y, x squared greater than y, and x less than y. There exists real numbers x and y such that x squared exceeds y, but x is less than y. This is true since we can take x equal 2 and y equal 3, for example. For all x, for all y, there exists z such that x plus y is equal to z. For every pair of real numbers x and y, there exists a real number z that is their sum. In other words, the real numbers are closed under the operation of addition. This concludes this lecture.